Good morning, gentlemen. I hope you guys are doing fine, staying safe at home and learning well. I know we have been indoors for very long, so some of us are feeling claustrophobic, are having cabin fever. We are just so frustrated that we have to be indoors all the time. But just hang in there because, after this entire period, we will all be able to come out and see each other again. And hopefully, this will pass really quickly. Okay? So stay hopeful and stay strong and stay safe. Now, we are looking at chapter 6 today. Page 8 to 10, we're going to cover about functions and basically in particular linear functions. Okay, so what is a function? Okay, so let's look at this diagram over here for what is a function. Basically, a function takes in an input and gives out another output. Okay, so you think about it as a machine. You take in an input, apply a rule to it, and then produces an output. So for example, let's say your input over here is 5 and your output over here is 7 and your second input is a 10, output is 12. Then when you input 15, you get 17. When you input 20, you get 22 as the output. When you input 25, you get 27. When you input 30, you get 32 as the output. What is happening is, for every input that you input into the machine, the function machine, the machine is adding 2 to produce the output. Okay, so basically this is what the function machine is doing. It is taking your input, applying a rule such as +2 and producing an output. Okay, so fill up the blanks over here. Both are function. Okay, so we're going to express the rule in words below, okay, for the above input and output. Basically, add 2 to each input to get the output. Okay, that's what's happening over here. Okay, so this entire information over here can also be represented by a table. So you see all the numbers here. We have rewritten the inputs 5, 10, 15, 20, 25, 30, and we're going to write the corresponding outputs. So for 5, the output was 7, for 10 was 12, 15 is 17, for 20 is 22, 25 is 27, and 30 is 32. Okay, so I'm going to express this entire information mathematically. I'm going to let x be the value of the input. Let x be the value of the input and y be the value of the output. Okay, so I'm going to call this input x and I'm going to call this output y. How can I form an equation with x and y such that I can describe this table over here? Basically, you realize that every output is gotten by adding each input to 2. So simply, mathematically, the equation will be y equals to x plus 2. And this is how I describe the function over here. Okay, now what do we do with this x and y values? Basically, we're going to form ordered pairs. Okay, what are ordered pairs? We're basically going to write the pairs. That means the value of the input, comma, value of the output for each of these columns over here. So take note that the x value always comes first, then you have to write a comma followed by the y value. So in this case, for example, this will be 5, 7. That's the ordered pair for the first column. Second column will be 10, 12. Okay, third column will be 15, 17. This one is 20, 22, 25, 27, and 30, 32 for the last column. Okay, and now we're going to plot these ordered pairs on the given coordinate plane on the next page. And after we plot the graph ready, we will be able to observe the relationship between the ordered pairs from the diagram. Alright, so how do we plot the points? Okay, if you turn to your next page, you would see the Cartesian plane given to you. So we will start off by thinking about the scale. Now, since our x values go from 5 to 30, and our y values go from 7 to 32, we need to make sure we fix the scale such that we can fit all these points into the Cartesian plane. Okay, so in order to do that, I'm going to keep it this way. For my horizontal axis, the scale I choose is going to be 2 cm to 5 units, which means you see the 10 lines over here, right? This big box over here, this is 2 cm. Okay, I'm going to keep 2 cm to represent 5 units so that I can fit 5, 10, 15, 20, 25, 30 on my x-axis. Okay, that is for my horizontal axis. I write the numbers here and I also label my axis with a X for the horizontal axis. How about the vertical axis? My numbers go from 7 to 32. So I need to make sure I can fit all the numbers on the vertical axis. Hence, the scale I'm going to choose is 2 cm to represent 10 units. So over here, one big square once again, 10 lines over here, right? To represent 10 units. So it will go from 10, 20, 30, all the way to 40 because I need to plot until 32. Okay? And of course, I label the numbers ready. I label the axis. I write down a Y over here for my vertical axis. Also, don't forget to label the origin. The origin is the place where the two axes intersect. So over here, label with a O for origin. Okay, then what am I going to do? I'm going to look at each ordered pair over here and start plotting. When I plot, I must make sure I plot with a cross and not a dot so that the points are very clear. Okay, and how do I plot? For example, the first point is 5, 7. So the x value is 5 and the y value is 7. So this is one line to represent one unit. 1, 2, 3, 4, 5, 6, 7. So 7 is over here and 5 is over here. I mark my first point with a cross over here. Okay, and then I do the same for the subsequent points. So 10, 12 is over here, put a cross. 15, 17 is over here. 20, 22 is over here. 25, 27 and 30, 32. Plot, 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 plot. And once you've plotted all the points, 6 points, take your ruler and pencil and draw a straight line connecting all the points nicely. Okay, you should get a nice straight line that passes through all the points. Okay, and of course, label the line over here with the equation y equals to x plus 2, which we already found out just now, right? So the equation of this line is y equals to x plus 2. You can pause the video now and do all this plotting and drawing of the line first and then come back. Okay? Okay, excellent. Now that you have drawn the graph, okay, we can answer the questions that follow. First question says, if the value of x is 22, what do you think is the corresponding value of y? Now, look at the graph that you have drawn. If let's say I want to find out what happens when my x value is 22, right? I'm going to start drawing or reading the axis over here at 22. Now take note that 2 lines represent 1 unit, right? So 22 is over here. You draw a dotted line upwards until you hit the line, the graph that you have drawn. Okay, and then you read the corresponding y value over here. So use a ruler and draw a dotted line upwards and to the left. Okay, and then read off the y value over here. You realize that your corresponding y value will be 24, which is of course true because if you look at the equation, when x is 22, y should be 22 plus 2, which is 24. So we are correct. Okay, so that's part D, or rather the part on your notes, which is, let me go down, yeah, which is also part D. Okay, and for part E, we already done it. Suggest an equation connecting x and y. We already know it's y equals to x plus 2. Alright, now if you look at your graph that you have plotted, how many different values of y are corresponding to each value of x? If you realize, for example, when my x is 10, I draw a dotted line upwards, I read off, there is only one corresponding value of y, which is 12. Correct? So, similarly, if let's say my x value is 15. I draw a dotted line up, I read, I realize that I only have one corresponding value of y. I can choose any point, for example, x is 6. I read over here, my y should be equals to 8. So for every value of x, there's only one value of y that is corresponding to that value of x. Okay, so write down, only one value of y corresponds to each value of x, which means this is a one-to-one function. Okay, it's a one-to-one function, meaning for every value of x, there is only one value of y. Alright, now we can conclude. A function is a relationship between two variables, x and y, such that every input x produces exactly one output y. Okay, so this is what we've learned so far. We've learned that a function takes in an input, applies a rule, produces exactly one output y, okay, for every input x. Okay, and we've also learned that the function connecting x and y can be represented by an equation of the form y equals to ax plus b, okay, where a and b are constants. What does that mean? Just now, the equation that you formed was y equals to x plus 2. Okay, so this is of the form y equals to ax plus b, right? Where your a is actually equals to 1 in this case. The coefficient of x is 1. And b, which is a constant term over here, is your 2. Okay, so a and b are just numbers, or rather constants. And your equation always looks like this form y equals to ax plus b for a linear function. Okay, so the plotted points, if you draw a graph, whenever your equation is this form, you go and plot, you draw a graph, you realize you will always get a straight line as you plotted just now. Okay, and we say that this function is a linear function. You plot a linear function and you get a line. Okay, so let's see whether these are linear functions. Y equals to 2x plus 1. Is this of the form y equals to ax plus b? Most definitely. So yes, okay. Your a is equals to 2, your b is equals to 1, right? So this definitely is a linear function. How about this one? Y equals to negative 4x plus 1. Once again, it does look like y equals to ax plus b, right? Your a is negative 4, your b is 1. So this is also a yes. How about this? Y equals to 2x. Y equals to 2x is also of the form y equals to ax plus b, just that your a is 2, but your b is 0. There is nothing added behind. But basically, this is the same as 2x plus 0, right? So it is still a linear function. And the last one, y equals to negative 3x, is also a linear function because your a is negative 3, your b is 0. Okay, so what is the defining quality of a linear function? It is the x to the power of 1 over here. You must have a y equals to a times x to the power of 1 for it to be a linear function. In Sec 2, you will learn equations of the form y equals to x squared, for example, where your x is raised to power 2. Okay, now this is not considered a linear function anymore because your x is not power 1, it is x to the power of 2. And we call this a quadratic function. So this one you don't need to know now, but if you're interested, you can try to use Desmos or any other graph plotting software. And you realize that when you plot y equals to x squared, you will not even get a straight line. Instead, you will get a curve. Okay, you will get a curve, something like that. Okay, so this is a quadratic function. It is not a linear function. For a linear function, you need to have a x to the power of 1 only. Okay, that's the highest power of x. Alright, very good. Okay, on page 10, we see a quick summary of how to draw graphs of linear functions. Step 1, create your table of values, minimum 3 points. Step 2, draw the axis. Find the scale that is suitable to plot all the points that is in the table. Step 3, plot the points with a cross. Step 4, join the points with a nice straight line with a ruler. And step 5, label the graph by writing the equation beside the line you have drawn. And you're done. Thank you.